we need to find the slope of that function. Okay, so one way to do that is to say we have two points. And so we're going to use this formula to find m, right? And we're going to use that formula to find the value of x where the function is equal to 0. So by replacing f of x by 0 in this function and solving for x, alright, you get minus f0 over m plus x0, or you can write it like that, x0 minus f0 over m equals to x. Okay, you can find work these out by yourself. It's actually helpful to understand better. So okay, so first we compute m the following way. So f of 1 x1 minus f of x0 over x1 minus x0. Then we return x0 minus f0 over m or we could also put x1 and f1. Alright, doesn't change anything. Either one will do. Let's try that. So a equals to 0.5, b equals to 1.5, say. You have to say so we're pretty far, right? Because the function is not a straight line, so that technique does not work really. But you can notice something. It is that we start with two values of x and we find a new value of x. So maybe the new value that we found is closer to the right value than where we began. So what we can do is to iterate, right? If we iterate, say, 10 times, iterate 10 times, we might get a better value. Let's see if we do. Okay, so the first thing we do is we compute m, and then we're going, so now we have three values. We have x0, x1, and x2. We don't want to keep having more values because we only need the previous two values. So the third value, we're going to set it as the previous value. So we're going to shift the previous value to the second previous value and the current value to the previous value. We can't do it in the other order because if we say the previous value is equal to the current value, then we've erased, there's no place in memory where we remember what the previous value was. So we can do x0 equals x1, x1 equals x1 minus f at x1 over m. Okay, so it got crazy. That happens, unfortunately. print what the value of m and the value of x1 . So we were like really not lucky, right? We were really unlucky because so NaN stands for not a number. We saw that previously. And what this thing did is it found the zero. Found the zero, and then if you could see, you know, it's the zero is 1, exactly 1, but it found it pretty close to 1, and at some point it was too close to 1. And when it becomes too close to 1, this kind of function, you know, what happens when we're very, very close to their actual root? Well, what's going to happen is that x0 and x1 are really, really close. So m is, it's going to be, you know, something